Welcome friends. In this video I'll discuss tool calling with Spring AI. Let's take a look. Some more AI generated art, this time for tool calling. I thought that was kind of nice. So Spring AI tool calling, what is it? Tool calling, also known as function calling, in the previous versions of Spring AI, so before 1.0, the API was actually called function calling. It is a common pattern in AI applications, allowing a model to interact with a set of APIs or tools, augmenting its capabilities. So we allow the AI to call into our program to execute some code to get some data out. Now, there's also a model context protocol, and this is a programming language agnostic protocol for tool calling. It is newer. Spring AI also has support for it, but we are not going to be doing that in this presentation, right? It's a little more involved. It requires you to make MCP servers and clients. We're not going to do that here. We're going to keep it relatively simple. All right, so our overview of what we're going to do. We're going to talk about making methods, turning methods into tools, and we're going to do that declaratively. Then we're going to make functions, and we're going to turn those into tools programmatically. Then we'll talk about tool inputs and tool outputs. What is the structure? How does this interact with each other? Basically, when we make a chat request, on that chat request, we'll also have tool definitions. They get sent into the AI model. And then if the AI model, based on the prompt, sees, oh, I could really use that tool to find out, right, things that I need for this request, then it will make a call to the tool, and that will hit our tool code, right? So it will do something. This could be as simple as getting the current date and time, but it could also be something like getting information out of a database, right? So it creates some data that gets sent back to the model. It processes it, and based on that extra information, it then makes its chat response. All right, so basically, it's a way to allow the model to call into our code to get more information. So there are different ways to create these tools. We can have methods that become tools, we can have functions that become tools, and we can do it declaratively or programmatically. We can do it declaratively and programmatically for methods, and we can do it declaratively and programmatically for functions. For this presentation, I'm going to stick with declarative for methods and programmatic for functions, because those I see as sort of the main ways, but know that you can do both ways, right, for both things. So that's 4 in total. That's just way too many things to talk about. So I'm going to stick with methods declaratively and functions programmatically. All right, let's go take a look. Declarative method, right? So tools, and declaratively turn them methods into tools. First off, our Maven dependencies. These are just the basics that I've been using in all these videos, right? I'm using the Spring Boot Starter Web and the Spring AI Ollama Spring Boot Starter. So nothing fancy. Then the first tool I'm making is a date time tool. And so here in my class, I just have a single method and I put add tool on it. Notice that the class is not a bean, right? It doesn't have to be a bean. If it's a bean, that's fine too, but it doesn't have to be. And we just add tool on our method. Now it's good to add a description on to describe the tool a little more for the AI so that it gets a better understanding of what it's for. Otherwise, it just gets the method name, which might be enough, but it's nice to give it that extra little description so that it, so that you can be sure that it figures out what it's for. Then I do use a logger so that I can see when the AI calls it. I get that little log line, which is nice for me, so I understand what's going on. Yeah, and so then that's pretty much it, right? Get current date and time. And why is this a good tool? Because LLMs don't actually know what the time or the date is, right? And so here, by giving it this tool, it can figure that out. Next, I also made a simple calculator tool for adding numbers together and for subtracting. Why, again, is this a good tool? Because LLMs are really bad at even the most basic math. They hallucinate all kinds of things, right? It's just, so giving it a tool to actually do computations, right? Doing additions and doing subtraction makes it so that they don't hallucinate. Here, we don't just see the tool description, but we also see the tool parameter description. Again, can be very practical so that the LLM properly figures out what goes where. All right, then in our Spring Boot application here, I'm going to add the tool as a default tool to my builder. The downside that you could possibly have with that, it might be available in situations where you did not want them. That's a possibility, but for this datetime tool, it doesn't matter that much. You can also therefore add them on when you're making the prompt, right here. So when I'm making the chat client, I'm making the prompt, I can also add it here, tools. I'm adding the calculator tool here. The downside of doing it here is that if you have lots of calls to this endpoint, you keep on adding it on again and again and again. So that's more CPU overhead, right? But so you need to find where adding the tool makes the most sense for you. All right, so we're adding those tools. It's time for a demo. Let's go take a look. So first of all, let me go run some code. I'm not sure if I'm running anything. First, I'm going to demonstrate that it doesn't know the current date at time. For that, I'm going to go to the chat memory. Remember from my first video, and I'm just going to run this one, and I'm going to ask it what the current date is, and we can see that it doesn't know. And I'm going to ask it to do a simple addition, and we'll also see that it doesn't know how to do that. So I'm going to ask what is the current date and time. So this is asking the AI without any tools to see, does it know, right? Does it know what the current date time is? And it probably says no, right? I am not capable of providing real-time information, right? Because it hasn't been trained on that data. It doesn't have access, so it doesn't know what the current date time is. And if I ask it, what is 1, 2, 3, 4, 5, 6 plus 654? It will have sorry about that, plus 654. It will probably hallucinate. Let's see if we get it to hallucinate. Yeah, it's totally hallucinating. That's not right, right? We'll get the calculator out. We'll see what it really should be. So that's 1, 2, 3, 4, 5, 6 plus 654. It should have been that, right? So it's hallucinating. It's bad at math, right? We can't blame it. It's okay. So let's stop it and let's give it the tools to be able to do these things. So I'm going to go over to tool methods. I'm going to run. And then I'm going to ask it again. Hey, can you calculate this now? Can you do a simple addition? And so it should figure out that it has the tool to do it, and then it should give us the right answer this time. Takes a moment, of course. There we see 124,000. Let's get the calculator up again. I'm pretty sure that's right, but might as well prove it. 1, 2, 3, 4, 5, 6 plus 654. There we go. And we can also see that it made a call to the tool here in the log, right? So over here, yes, adding 1, 2, 3, 4, 5, 6 and 654. So we see that it is using our tool, right? Here the log line is calculator tool, right? So we see that it's doing it. Let's ask it about the current date and time, and you'll see another interesting thing, and that's actually related to my system time. So what are the current date and time, or maybe what is the current date? Okay. We'll take a moment, and it should be able to figure out the current date and time based on the tool. Of course, I am running on old hardware, so we see it's working hard to try and figure out. Current date is April 8th, 2025, and the current time is 8:52 a.m. Central Time, America, Chicago. Now, my computer is set to America, Chicago, and it currently is 8:52 a.m. in Chicago, but I'm not there. I'm in Europe right now where I'm recording this. My current time is actually 3:52, not 8:52. right? As in 15:52, 3:52 p.m. So I'm going to fix that coming up, but let's continue on for now because we see it's using our tool correctly. All right, now these method-based tools have some limitations. So the following types are not currently supported as parameters or return types for methods used as tools. Optional, no asynchronous types like completable future and future, no reactive types like flow, mono, flux, and no functional types like function, supplier, and consumer. Functional types are supported though if you use the function-based tool specification approach. All right, let's do that. Let's do the function-based approach. So the first thing I'm going to build is an addition tool. Why not a complete calculator tool? Because the calculator tool was really two things, right? Addition and subtraction. And they just require a lot more code or more code, right? In order to make this work, I had to make an addition tool that implements the function addition request to addition response. And then I have to have separate files for a record for addition request and a separate file for addition response. Let's go take a look at that code here as well. So this was in tool functions. Let's close all this off. I'll shut this down for a moment as well. So this was tool context, tool functions. There we go. So here we see addition tool, right? And it uses addition request and addition response. So addition request takes too longs, and addition response takes a result, right? So we have to use more files. It's okay, we can still make it work, but the programming experience is a little less for a simple tool like this, having to make 3 files. Now, connecting that up is a little different as well. We're no longer using annotations, right? We're doing programmatically. How does this work? We're going to make a tool callback called addition tool using function tool callback dot builder, giving it a name and the class of the function, right? It's a function class. Then we also, of course, need a description. Previously, we were putting description on the annotation. Now we should put the description here in this extra method call. Then the input type is an addition request class, right? So we configure it this way with the function tool callback builder. Then we just add it on, right? So we say our builder gets the default tools and we give it this addition tool. We could also add it onto the prompt, right, in the controller. That would have worked the exact same way, but I felt this is a good place to do it here. All right, let's demo this. So I'm going to make this this work. Let's go over to tool functions, and I'm going to run this. And let's take a look if we can add some numbers. So I'm going to say, what is 1, 2, 3, 4, 5, 6 plus 6, 5, 4? Okay. We'll have to wait a moment as it goes through. And again, I put that log line in so we should be able to see it in the log here coming through as well. Okay, I think let's take a look at the answer first. So I'm pretty sure it made the correct call. So that's 1, 2, 3, 4, 5, 6 plus 6, 5, 4. Right, that's the right thing. And let's take a look here in the log. Adding. See, it's doing the adding. All right, so we've seen how to use functions, right, as tools as well. And so far we see, right, it's pretty straightforward to make our API, our methods, our functions available to Spring AI. Now, just like there were some limitations on the methods, there are also some limitations on when you're using the functions. So the following types are not currently supported as input or output types for functions used as tools: primitive types, optional, collection types like list, map, array, and set, asynchronous type like computable future and future, and reactive types like flow, mono, and flux. Primitive types and collections are supported though if you use method-based tool specification, which we looked at just previously. Now, there's one thing that's a little interesting here because it says primitive types are not supported, but if I look at my code, right, with the addition request, I most certainly use primitives. So that's a little strange. Maybe the documentation was a little outdated because clearly I am using primitives and clearly it does work. So I'm not completely sure what they mean with this, but I seem to be making it work, but maybe I'm misunderstanding something. All right, so let's talk about inputs, right? There are some more options around inputs. It's good to discuss them. The first one is that you could have certain parameters that are optional. By default, all parameters are considered required. But you can make a parameter optional by using add_tool_param required equals false. Now, if you're using Jackson or Swagger, you could say JSON property required false. Maybe you already had that annotation, right? Because you were using that anyway, right? Or schema required false from Swagger. Maybe you already had those, then you don't have to put tool_param from Spring AI on it. Or maybe you already had add nullable on it just from somewhere else from Spring Framework. So any of these annotations will do. It will figure out, hey, this is an optional parameter. And so then the AI doesn't have to provide it. Also, descriptions. We already saw tool_param equals description. But if you were already using Jackson and had JSON class description, or JSON property description, and we're already describing it there, then you could just use those. You don't have to use add_tool_param. Or again with Swagger, add schema description. Again, it figures it out. It's like, hey, yes, I can use that. And then it uses that. Then you don't have to duplicate your effort with additional annotations. Lastly, I want to talk about tool context. It's an additional input that we can do into the tool, which is provided by us, not by the AI model. So when the AI model makes a call, not only does the data go into the tool that got provided by the AI, but also data goes into the tool that is provided by us, right? The context is extra data that you give to the tool. This data is not given to the LLM. All right, let's take a look at this example. Remember, it wasn't getting my date and time quite right. So what we can do is we can adjust it by giving it a little bit of extra data from us, right? So I'm going to say I'm going to make a default tool context with a map, key value pairs, saying the zone that I'm actually in is Europe, Amsterdam, and the hour should be adjusted 7, right? I have to make it a long because that's what the API requires, but fine. So I'm going to adjust the time 7 hours into the future and say we're actually in Europe, Amsterdam. Let's see how I do that. So over here, get current date time used to not take any parameters, right? Because it just says, hey, can I get the current date time? But now I'm going to give it that tool context, right? Where these values are going to come in. So with the tool context, I pull out the zone, turn it back into a string, and now I get the zone ID from that. And I pull out the hour, turn it back into a long, and so I get the hour. And then I adjust, I say local date time now plus hour 7, right? There was a 7-hour time difference at zone. And so now it will give it to me correctly based on this extra information that I'm passing into the tool. All right, let's demo that. So I'm going to go over into the CD tool context and then run it here. And then I'm going to ask, what is the current date and time? It will take a moment. And we'll see it, of course, in the log lines as well when it goes and makes that call. Not yet. Again, I am on old hardware, really pushing the limits. Okay, here we go. So 4:02 p.m. Excellent. That is indeed my current local time. Oh, and it changed the time zone. CET. That's the Central European time zone. That's correct. That's correct. That's where I am. Well, let's take a look here to see that it made that call. Tool get current date time is zone Europe Amsterdam. There we go. Time 16:02. Very good. Very good. So that works. All right, then let's talk about tool output. There's two things here as well that you might want to change or you know, be able to modify a little bit. The first one is return direct. Remember, normally when the tool gives an answer, that answer goes into the AI model, which then interprets it and then gives a response. But if you don't want the AI to do the extra interpretation, you just want it to go straight to the user, right? Straight into the chat response. You can do that as well. You just have to say on your tool, hey, I want this to return direct. Let's see that. So here on my calculator, I said, hey, I want to return this direct, right? I don't need the AI to spend more time interpreting this. Just give it back, right? So both for my addition and my subtraction. Let's go do that over here. So I'm going to go into tool return direct and run this. And then I'm going to ask it, what is, I guess I'll ask it the same as before, 1, 2, 3, 4, 5, 6, plus 6, 5, 4. And it should return just the number right away once it gets the number from the tool. So it, of course, takes a little while. There we go. And so we saw that it didn't take quite as long as before because it didn't have to go through the AI again. And we definitely get the right number. We saw that number before. All right, so that is return direct. Then there's, and I did demo that. Then let's talk about result conversion. I'm not actually going to demo this. I think it's good for you to know about, but I'll just tell you sort of how it works. So by default, the result is serialized to JSON using Jackson, the Jackson library, using the default tool call result converter. But you can customize the serialization process by providing your own tool call result converter, right? So if you're unhappy about how the data is coming out and going back into the LLM, into your AI, you can modify that conversion process, right? So that you are more in control of the data. So basically here, you can implement this interface, the tool call result converter, where you take a string, a nullable object result, and a nullable object result return type. And then on the tool, for instance, here's a customer tools. When the AI would ask for get customer info, right? Retrieving customer information, we give it a result converter, our custom tool call result converter, so that it uses that when it gets the customer information out. Maybe we want to hide some fields or do any other kind of data manipulation on that customer data before it goes to the AI. All right, so yeah, it's just something that it's good for you to know about, that you can have that control on modifying the data that comes out of the tool before it goes into the AI. All right, so that's it. In summary, we saw declarative methods becoming tools. We saw functions becoming tools programmatically. We talked about some more things for tool inputs, and we talked about some more things for tool output. Some closing thoughts. Tools can add practical capabilities to LLMs. Putting this together really made me experience the limits of self-hosting on old hardware. Yeah, so I tried to have, because there are some examples for that in documentation, I tried to have Llama 3.2 set an alarm for 10 minutes from now. Because then what it needs to do is it needs to get the current time, add 10 minutes, and then make a call to a set alarm tool. And it never did it. It never did it right. It tried to make a call within a call, right? It tried to give syntax for a function call into the string that makes the alarm, setting the alarm work. So it does try, but it would never actually do two calls, because that's two calls, right? One call getting the current time, one call setting the alarm. Could not make that work. Now, I'm not sure if that's a problem with Llama 3.2 or if that is a problem with Spring AI. And so I'm interested in testing this with OpenAI, but again, I don't really want to pay, right? I'm not interested in paying their subscription. So at some point I'll test it. Also, then I tried a whole bunch of other models, but many models don't actually support tool calling. It's a relatively rare thing. And I actually downloaded some other models and didn't have much success with that either. All right, that is it. I think this is going to be my last video for Spring AI for a while. Be sure to like and subscribe, all of that, and I'll see you later. All right.